All right, let's start with just dragging in all our sprites here. And next, I want to show what we're going to be doing. So if I come in here, let's say I have a shoulder joint, I have an elbow joint, and I have a hand. That can create a triangle by just taking the length of the upper arm and the lower arm, and then I get the distance from the shoulder to the hand. I now know the sides, 3 sides of a triangle. I can use the side formula to calculate the angles for each side, and then I could just set, like, I want the hand to be here, and then run that formula, and it spits out the angles, and I just set the joints to be at those angles, and then the hand will be at that position. I don't have to animate it custom or anything. It just does it all for me. Now for the spider though, it's going to have 3 segments, and that means 3 joints. So what I do here is I just add on another triangle, and this side is going to be calculated based on this total length. I'm going to take the distance from here to here and divide it by that total length, and that gives me a percentage. And then I'm going to multiply that times this plus this length, and that'll give me this side here, this fake side of a triangle. And then I can just add these angles together for this rotation, use this one for this one, these 2 for this one. So if I go in here and I just add in a position 2D, call this leg, and then as a child I'll add in the sprite, and I'll also add in another position 2D, and I'll call it joint 1, duplicate that and make it a child, duplicate the sprite and make it a child of there, and then duplicate this, make it a child, and I'll call it hand, and then I'll duplicate this sprite, put it here, again call it sprite. Now I'm going to go onto this sprite, and we're going to put in the upper leg, this one we're going to put in the middle leg, and this one we're going to put in the lower leg. And then I'm just going to rotate this first one like that, and then move it over like that, so the base is at the starting point. And then this joint one, I'm going to hold shift and then move it along the x-axis until it's right about there. Rotate this like that, and then move it over there about. Take this joint and hold shift, move it over to there. Rotate this, and then just move it over to about there, and then move the hand to the end here. And you just switch between move mode with W and E. And now I'm going to add a script to this. So for our math, we need a few things. First off, minimum distance. I don't want to get closer, allow the target point to get too close, otherwise the side calculation starts returning nan, or not a number, which is bad and will screw things up. Then I get references to each joint and the hand or end point. Then I need to get the lengths of each limb segment, and then this will just control whether or not it's flipped. So I'll use this for a front or back leg. I'll just flip the angles and the sprites. So in the ready function, I'll just set the lengths to be the local x position of each joint, which is why I only moved it on the x-axis. So that basically gets you this local x position of this joint will be the length from here to here, and same for the rest. And then I just need to do this, check if flipped is true, then flip all the sprites. Now for our math. So I need to do the law of cosines, which is a squared plus b squared minus c squared divided by 2 times a times b. And I take the arc cosine, and this will give me an angle based on, so if these are the 3 sides of a triangle, based on the order I pass them in, it'll give me an angle of one of the angles of the triangle. But I also want to check if this 2 times a times b is 0, just return 0, because otherwise I'll get a divide by 0 error. And then next, I need to come in and do the side calculation. So I pass in the 3 sides, and I'm going to get all 3 angles out. So I just check if the side C, which is the distance from the base to the end joint, is greater than these two sides, then that means the target's too far away, and I just want to return 0 for each side. Notice how I use a dict, so that way I can just do like angles.a on whatever I return, just easier to access. So I just set it all to be 0, so it's just going to point at the target instead of try to do some calculation and rotate and mess something up. Then for angle A, I just get, so in here, if you look at this, side A is here, side B is here, side C is here. Every angle is the opposite of its side. So this is side A, this will be angle A. Side B, angle B. Now, in here, for angle A, I just pass in the side B, C, and A. I just pulled most of this from a math website to figure out the order of doing this stuff. For angle B, I have to add pi because in Godot, this is rotation 0, right? And so if I calculated I needed to be at angle 30, so like let's say this was 30, in Godot, 30 would be, so what I need is it to be like this, but in Godot the angle 30 would give me here. So I add pi, which is like 180 degrees, and then that will give me the correct rotation there. And then to get the third side, you just subtract pi, which is the internal 180 degrees, right, minus the other two angles, and you'll get the third angle. And then next, we just need to check if flipped is true. We just negate all the angles, and then we return the angles as a dict here, A, B, and C. So now we can come into the update IK. So to start off with that, I have an update IK function. We pass in the target position, and then we get a vector pointing at it from our position. So just subtract target by global, and then get the distance of target, which is just the length of that vector. And then I check if the distance is less than the minimum distance. I divide the offset vector by its length to normalize it, and then multiply it by the minimum distance. And then, so that gives me a vector of length min dist, and then I set the distance to be minimum distance. Next, I get our base rotation, which is just the angle of the offset. So that's the angle from our base joint to the target position. And then I get the total length of all the limb segments. And then I get the length of the dummy side, which is just the upper and middle. Like I showed here, it's this plus this times the total length, or the distance from here to here divided by the total length, which is that, and then that is clamped between 0 and 1, so it'll just be a percentage. And then next I need to do, I get the angles, so doing side calculation. So the base angles is the black triangle, and next angles is the red triangle here. So side A for this one is the dummy side, side B is the lowest length segment, and then side C is the distance. And then for the other one, it's upper, middle, and dummy. And then I just set all the rotations based on that. So our global rotation is going to be, this is angle B, so this is side B, so this is angle B, side B, angle B. So I just add both angle B's together, and then I add that to our base rotation. And then this joint 1 is side C, angle C of this. So if this is side C, this will be angle C. And then the joint 2 over here will be base angle C, which is this one, plus A of this one. So that's side A, angle A. So I just add those two together, and that gives me the correct angles. So now I'm just going to test this by, in the process method, I'm just going to call it and pass in our global mouse position. So let's just save this, hit F6 to run this scene. Now you can see it there. And if I go over here, you can see how it works. If I bring it in, if I get too close, then it can't go in anymore. Otherwise, it looks pretty good. And if I flip it, then it goes the other way, see? And let's just move it back to its original position there. So now I need to do some procedural animation stuff. So for that, I'm going to have a few values here. We have our goal position, our intermediate position, and our start position. So wherever the foot's at, when we call a step function, that's going to be the start. The goal position will be our goal position or reach, and the intermediate position will be in the middle and slightly higher. And so step height determines how much higher it is. Step rate is how fast a step goes, and then step time is how far through a step we are. So to set up step, let's create that. We're just going to check if our new goal position is equal to our current goal position, and if it is, then don't do anything. We don't need to take a step if we're already there. Otherwise, update our goal position, set our hand position to be whatever the end hand position is, then calculate what the highest point is. So basically what we want to do is if the goal position and the start position are at different heights, pick whichever one is higher, and then add the step height to that for the intermediate points position's height. So we just take here the highest, set it to our goal position, and then just check if the hand position is higher. Remember, negative is up in Godot, so we do less than. We just check if this hand position Y is less than the highest, and if it is, then we update the highest to be that one's. And then we just update all our positions, so just mid is going to be the goal position, the mid of, oops, I didn't copy everything there. The mid horizontally is going to be the goal position on the X and the hand position on the X added together divided by 2, and that'll give you the mid horizontal point. Set the start position to be whatever our hand's currently at. Intermediate position is the mid on the X and the highest minus step height. Remember, because negative is up, so you minus to make it higher. And then for the Y there, and then update step time to be 0. And then for process, we need to clear out that and just go in step time, add the delta to it, target position, just set that to 0. And then go in here, and we're going to get how far we are through the step, which is just step time divided by step rate. That'll be a value of 0 to 1. And then we just check if it's less than 0.5, we should be going from, we just set it to interpolate between the start position to the intermediate by t minus, or divided by 0.5. So that'll mean at 0, when t is 0, we'll be at start position. When t is 0.5, this will evaluate to 1, and it'll be at the intermediate position. Then from there, we'll just check. So if we're not less than 0.5, but we are less than 1.0, then we interpolate from the intermediate to the goal position by this, so t minus 0.5 divided by 0.5. So that means when t is 0.5, this will evaluate to 0. When it's at 1, this will evaluate to 1. And then finally, we just check here. Otherwise, set the target position to be equal to the goal position, and then finally we call update IK using our target position there. Next, let's create the actual spider itself. So go in here, let's add in a kinematic body 2D, call it spider, and let's add in a sprite, and also add in a collision shape. This isn't really necessary, but it's just to get rid of the warning sign that appears on a kinematic body if you don't have anything. So I just add something there. On the sprite, I'll add in the body texture, and then add in a node 2D, call it front legs, and I'm going to get instance a leg here, another 4 of them, and I'll just move them a little bit. so they're a little spread out. And then duplicate this, and I'll call it back legs, and move them back. And then for these ones, I will set flipped to be true, I think. I might have that backwards, but I can always edit it once I see how it looks when I hit play. And then finally, add in a raycast 2D. I'll call this low, mid, check. Duplicate high, mid, check. Duplicate front, check. And then back, check. And then I'm just going to go on all these and click enabled. Then front check and back check. I'm going to set these to be like 500 on the Y for cast 2. Low mid check, I'll do like 220, and then high mid check will be 200. So I'm going to move the front check to be like right there, and the back check will be like right there. So what this is going to do is the front check, this whatever it's colliding at, the collision point will be used for determining where to place the legs, where the goal position should be, and the back check is for the back legs goal position. These mid checks here, the spider is just going to keep the ground between these 2 points is what these are for. So if this low check here isn't hitting something, it's going to lower itself down until it is hitting something. If the high check is hitting something, then that means the ground is like up here or something. Then it's going to raise itself up until it isn't hitting something. So it's always going to keep the ground between these 2 points. Then let's add in also the camera and just do current. And then on the spider, let's add in the script here. So first off, we need to just get references to everything. So our sensors here, all 4 raycasts, just get references to them. And then get references to all the legs, the front legs and the back legs, just arrays of them. We're going to have export vars for horizontal and vertical speeds, and step rate, time since last step, the index of the current front and back legs we're using, and a boolean that determines whether or not to use the front or back leg when we take a step. So for the step function, let's start with that. We're going to initialize a couple variables, leg and sensor. And then if front leg use front is true, we set the leg to be front legs, whatever current front leg index is, and then increase the index and modulus by the size, the number of front legs. So if it goes, past if we have 4 legs, then if this gets up to 4, we modulus by the size, and that'll be set back to 0. And then sensor is just going to be the front check. And then if use front is false, we do the same thing, but for the back legs, and just use the back check. And then we just alternate the use front value. And then next, we finally check, set the target to be whatever the collision point of the sensor is, and then we call step on that leg and pass in the target position. So that's just the step function from our leg script that it's calling. Now we need to do just a simple, in the process script, we just call increase time since last step by delta, the time since last frame. If it's past the step rate, set it to 0 and call step. And then for our movement, we check, it's pretty simple. We just have a movement vector, set the horizontal movement to be x speed. And if the high mid check is colliding with something, set our vertical movement to be negative y speed, so just move up. And if the lower one is not colliding something, then move down. And then finally just move and collide. And then for the last step we need to do, in the ready, so right now if I hit start, all the legs are going to just be sticking forward like this, which looks dumb. So what I need to do is come into ready, and I'm going to update the front and back raycast. So what happens in the ready, they haven't collided with anything yet. So I have to force update them. Otherwise, they're just going to return 0, 0. Now they'll get a collision. Now that I've called this, they'll collide with the ground. These two checks here. And then I just call step 8 times, so it'll step each leg at the same time. So they'll just reach down and touch the ground, basically. And then I'll just save that. And then we're going to create a new scene. New 2D, call this world. Add in let's instance the spider first off. And then add in a sprite. And I'm going to drag on this icon here. And visibility, modulate it to black. And then just add in a static body. And then add in a collision shape. And set it to a rectangle shape. Set the extents to 32 by 32. And then move that down here. Oops, move the sprite down here. And then just Q, scale it out a bit like that, and back to W. And I'll just Control D, kind of make a little simple environment here. So we can test it out. And let's just save that. F5, let's select this as the main scene. Let's see if I got the legs backwards, hold up. Sprite, spider here, come to the back legs here, disable flipped, and set flip to true. Again, run that. There we go. So now you can see the spider here. Now something you'd probably want to do is make so it starts raising or lowering itself in advance when it sees, using the front check maybe, when it sees a rise or a fall. And other cool things you could do, you could use the IK for like an attack, so you just set the target here and make the step go to the player's position as the goal position, so it draws in and then kind of shoots out. And we're done.